Fantastic. Hello. Welcome to Data Science Festival. My name's Tom. I'm going to be MC for the command room, which is the room we're all in for this morning. My amazing assistant, Marvia. Say hi, Marvia. Hi, guys. He's going to be helping out with the room and also dealing with the questions that come up as a result of the talks. So a little bit about Data Science Festival and how you can get around and things to do, not to do, so on and so forth. You each have a booklet in your swag bag that will tell you the event schedule, so you can see all of the talks, what time they're going to be and what room they're going to be in. If you've got any questions, ask a Data Science Festival team member. We'll either have one of these hoodies with that on the back, or we'll be sporting a t-shirt like Marvia's wearing. You do have water at the side of the room. Historically, this room does get a little bit on the hot side. So yeah, we do have a fan, but it can only do so much, and it's quite a big room. So please help yourself to water and try not to disrupt the session when you do so. Similarly, try and keep the room tidy. There's a bin there for your rubbish as well, and make sure you take all your belongings with you when you go to the next session. In terms of toilets, if you go out of the room, turn left, the toilet should be on your right. There's also a set of toilets upstairs in the main conference room as well. They're just to the left of the main stage, and you go through a little kind of white alley thing, and they're on your left. So I've got a couple of things to read. So the DSF is a celebration of all things data. We aim to connect the tech community and foster the sharing of knowledge, inspiration, and ideas. Just a reminder that all talks will be recorded and uploaded to the DSF website and YouTube channel. If a room is full, please wake your way to another one, and you can watch back any talks you've missed. The event is free to attend and built by the community. Without the help of our sponsors, we couldn't make this event the success that it is. So thank you to Data Idols, BSI, Unidays, Future Coders, Superlinked, IIRIS Informa, that just rolls off the tongue, SDG Group, Digitus, dunnhumby, NVIDIA, Snowflake, Create Communities, and finally CodeNode, who provided us with this fantastic venue. Thank you to everyone who comes. You do help make these events as amazing and wonderful as they are. Just to kind of, in terms of the wider stuff we've got going on, we actually have a festival area outside in the main foyer. And you will get a free popcorn at lunch. If you want your free popcorn pass, it's on the back of your booklet. And similarly, there is a competition to win £500 in cash. All you have to do is snap a selfie with your popcorn, post that to LinkedIn, tag MQCube and Data Science Festival, and use the hashtag DSF Mayday. Now that's not actually bad odds, because there's about 1,000 people here. Maybe 30–40% of people are going to do it, so you've got a 1 in 300 chance of winning £500, which is, you're not going to see better odds than that. We're all probability-based data science, we all know this, but I'm just reiterating it for you. So yeah, we try and make this event fun, so please, chat to other people, explore the festival zone, and hope you enjoy the day. Okay, so on to our first speakers. Sorry, I've got to change the page. Not thought this through. So, first of all, we're joined by Grace and Pardis, and their talk, Can We Trust AI? Grace joined IBM Client Engineering in September 2021 as a degree apprentice working as a technology engineer while studying towards a technology degree. During her time at IBM, she has been involved in various proof of concept projects for clients across different industries. Through these experiences, Grace has developed a range of various technical skills, including expertise in integration tools, virtual assistants, and programming languages such as React and Python. On her left, Pardis is a computer science student and has been working as a technology engineer intern at IBM since August 2023. She has gained strong technical experience by working on a number of cross-industry client-facing MVPs through hands-on project work and showcasing solutions. She has developed her skills in full-stack development, Watson X, artificial intelligence, and integration tools. Can we get a round of applause for Grace and Pardis?
Thank you. Great, thank you very much.
Cool, so thank you. Just before we begin, does anybody have any experience with virtual assistants? Maybe we can do that by a show of hands. Okay, a few?
A few, okay, cool. So thank you all for coming. This is our talk on Can We Trust AI? So we had a great introduction, thank you. But let's quickly introduce ourselves before we go in. My name is Pardis Farahi. I'm a technology engineer at IBM, and I've been working at IBM for around 9 months now. So I get to work on a lot of cool projects. I get to work full stack, be really innovative with AI, and even build virtual assistants. And in some cases, using our Watson X product from IBM.
And I'm Grace Burdett, also a technology engineer working for IBM's client engineering team. Again, I've been here almost 3 years now in September. And similar to Pardis, I've worked on a lot of cool full stack projects, but most recently I've been working and building virtual assistants, again, using IBM's Watson X product. Just a bit about client engineering. We're a pre-sales team that sits within IBM technology, and we build out minimal viable products to help solution pain points that our clients may have.
Cool, thank you. And we just want to highlight before we go into our presentation that the views and opinions expressed in this presentation are of our own and don't necessarily reflect the opinions or positions of IBM.
Cool, so we'll just go over a quick agenda. So the first thing we're going to do today is we're going to look at what AI is and its relation to virtual assistants. We're then going to look at positive use cases of virtual assistants and then go into some examples of where virtual assistants have gone wrong. We'll then look at a bit over how we build out virtual assistants. So we'll look at the technology behind it. We'll go into a bit of a demo architecture, and then we'll do a demo where we'll battle out 2 differently trained virtual assistants. And finally, we'll do a couple of key takeaways that we think you should take away from our talk. We'll have any time at the end for any questions.
Great, thank you. So we'll go over what we mean by AI and virtual assistants. So IBM defines AI as technology that enables computers and machines to simulate human intelligence and problem-solving capabilities. And within AI, we have something called generative AI or Gen AI, something that's become a bit more prevalent in today's technology and you might have heard of. So with generative AI, AI is able to create original content, that content being text, images, audio, videos, and even code, using prompts given by a human and data that it has been trained on. And on the other side, we have virtual assistants, which are digital agents used by humans to carry out specific tasks, such as answering any questions that they have. And when we combine those 2 bits of technology together, that being AI and virtual assistants, we get the concept of an interactive digital user interface that humans can use to carry out any tasks that they have, but with an enhanced user experience.
Cool, so we'll look at some positive use cases of virtual assistants. But what you might not know is the first virtual assistant that came about was in 1966, and that was called Eliza. It was created by a MIT professor called Joseph Weisborn, and it worked by connecting a typewriter up to a mainframe, and the user would type in what they wanted, and the Eliza would come back and replicate almost what the user had been saying. So it wasn't too intelligent, but it was able to pass the Turing test. But more widely recognized, rather, the first virtual assistant didn't come around until 2011, and that was Apple's Siri. And it's crazy to think that Apple's Siri links into anything we do in our day-to-day lives. It links to whether we want to ask a question at home or whether we're out and about. And it really impacted the way we think about virtual assistants today. So virtual assistants are used across all different industries. And in the first industry, it's used in banking. And that was NatWest Cora. So maybe in the past, you may have had to go into a bank to go and ask for a new PIN number or ask anything relating to your account. But now you can log online and go and ask the assistant, saving a lot more time than what you might have used to have done. It's also impacted other industries, such as the telecommunication industry. So similar in the past, you may have had to log online to go and help with your broadband. And an example of doing that is Sky. And again, in the travel and tourism industry, the same again. You can book holidays online now, which makes life so much easier. And you can also ask them any travel queries that you may have. And they're making our lives so much more simpler.
So virtual assistants can and they do go wrong. You may have seen cases in the news where this has happened, or even experienced it yourself where a chatbot hasn't really been able to give you an answer that you were expecting or wanting at all.
So most recently, some of you may have heard about the Air Canada case, but some of you may not have. If you haven't heard about the Air Canada case, it was a simple case where an Air Canada chatbot told a passenger that they were eligible for a bereavement fare after they were flying to their grandparents' funeral. But sadly, when they applied for it after the fact of flying to the funeral, they were declined it. And there was a whole palaver of whose responsibility it was. Air Canada argued that it wasn't their responsibility despite it being their chatbot, whereas the passenger argued that it was their responsibility because the chatbot sat on the Air Canada website. As a result, the passenger did take the company to court, and the court ruled in the passenger's favour, and Air Canada had to pay the passenger £642.64 in tribunal fees and damages because it was their fault. And so it raised the question of who takes responsibility. Even though this was resolved, it's maybe a moment to think about who would you think to take responsibility of it.
Cool, so this is a bit more of a light-hearted example where DPD, a delivery service, had their chatbot go completely off script. So what happened was that a user was frustrated with their experience with DPD and the fact that their chatbot couldn't really answer any of their questions. So what they decided to do was to see how far they could push it. And through questions, they were able to sort of bypass the rules that the chatbot was probably trained on, that being probably not swearing or criticizing the company. So in this photo on the left, you can see the chatbot swearing, calling DPD the worst delivery firm in the world, and calling itself useless. So here's some more examples. I'll play this video for you now. So what sort of looks like a regular customer service chatbot interaction sort of then starts to go a bit pear-shaped. So we got the customer asking it to tell them a joke, and then to write a poem about how useless it is, which it then does, quite a long one as well, clearly had a lot to say. I'll let you read through that. Cool, so the question arises again, who takes responsibility? And similarly to the Air Canada case, it was DPD that took responsibility. They had to disable the chatbot from their website in order to train it, update it, and to ensure that this wouldn't happen again. And there's also a risk too with things like this, where this could be a hit to a company's reputation. So this post was viewed a large number of times, to be precise, 800,000 in the first 24 hours, and obviously more after that. And also, this did indeed make the news. So there are different ways of building virtual assistants and training virtual assistants. One way is through natural language processing, or NLP. So NLP allows virtual assistants to understand human language, to be able to interact with humans, and also the intent of different questions. And some common virtual assistants that use this technique are Apple's Siri and Amazon's Alexa. So you're able to use your voice to ask it a query or a question, and then it's able to come back with answers in more of a conversational flow. Another way of building virtual assistants is using large language models, or LLMs. And one common virtual assistant that uses LLMs that you probably all have heard of is ChatGPT. So the difference between NLP virtual assistants and LLM ones is that LLM virtual assistants are able to not only generate information or answers from the chatbot's memory, but also from other resources as well that could possibly be publicly available, such as documents or websites. And the fact that these responses can be generated using these external resources and is done by the chatbot or the LLM itself, this means that this is a form of generative AI.
So in addition to this, there are many tools and platforms that you can use to train virtual assistants. And over the course of the next section, we'll look at various tools like that, but we'll also think about and touch upon areas that you might need to consider when designing or implementing virtual assistants, rather. So many companies have different platforms which they use. So for example, Microsoft have their Azure AI platform, and Google have their Vertex AI platform. But there are also many open source options such as PyTorch and OpenAI. Something that we're both familiar with is IBM's Watson X platform, and they have 3 core components and a set of AI assistants. Those components include WatsonX.ai, WatsonX.data, and WatsonX.governance. WatsonX.ai is a tool which is powered by foundation models and traditional machine learning. Again, there's different conversational AI platforms that you can use, both open source and closed source, and one such tool, again, that we're both familiar with is the Watson X Assistant, and this tool has the capabilities to be powered using large language models. In addition to this, there are open source alternatives, like I mentioned earlier, that you can use, such as Leon.ai. And this next bit, we're going to talk about language and tone, and whilst this isn't really a piece of technology, we do think it's important to highlight, because when you're training virtual assistants, you really want to think about what type of language you're using and what type of tone you're using, because if you don't use the right tone, it could come across as quite robotic or rude for the user. So for example, if you're creating a virtual assistant that is going to help a user find an example to their banking query, for example, you would want to train the virtual assistant using direct language, but in maybe like a sympathetic tone, so it's really understanding what the user is asking. And typically, conversational flow diagrams are used to kind of support you with this, so you'll map it all out first before actually implementing it into the assistant.
Cool, thank you. So we want to show you a demo where we battle out 2 different virtual assistants, but we want to go over what exactly it is that we want to show you. So we have our user who interacts with the virtual assistant. That could be via question or a query. And the virtual assistant uses a large language model, an LLM, to generate an answer to that question and then return it back to the user, which is what they will see on their screens. But in our case, we've got 2 different virtual assistants. We've got one using an LLM that is not trained on data related to our use case, and one that is. And our use case in this situation is DPD. So the situation that we explained to you earlier, where the chatbot went wrong, and just DPD in general. And the LLM that has not been trained in this area, we just found loads of random facts on the internet and stuck it in there and hope for the best. So we'll go on to our demo.
Cool. So here we're going to have 2 basic virtual assistants, and Pardis gets the demo up. The virtual assistant that we can see on your left, to figure that out for a second, is the one that's been trained on random facts, and the one on the right is the one that's trained on the DPD data. So the first question we're going to ask is, where does DPD originate from?
If I can type fast
Yeah.
enough. If I can type.
And we're going to copy and paste the same question from the first assistant into the second assistant, so we can really see the 2 different results. So on the one on the left, it's saying 50, which doesn't quite seem to be the place. But on the right, it's saying it's from Aschaffenburg in West Germany, which sounds to be about right. The next question we're going to ask is, what is DPD? And again, we're going to copy and paste the same question to give it a fair test. And you can see the assistant on the left that's been trained on the random fact is saying 54, so it has a thing for numbers clearly. But the one on the right is saying it's one of the UK's leading time-critical carriers. We're going to ask it another question. So this time we're going to ask a question around how many people work at DPD. And on the left-hand side, we can see it says 46, which I'm not quite sure is correct for one of the UK's leading time-critical carriers. But on the right, it's saying 48,000, which again sounds about right. The next question we're going to ask is, where was the Eiffel Tower supposed to be built?
Was
the Eiffel Tower supposed to be built in France? And the one on the left-hand side says the Eiffel Tower was originally intended for Barcelona, but yet the one on the right-hand side is saying chat DPD.
It wishes, yeah.
And then we're going to ask it one last question.
Yep.
I can't remember off the top of my head.
And the last question is, let us double check. It was, how much interaction did the article on the DPD chatbot get online? Which we will ask that now.
So the one on the left has said whatever, so I think it's given up by this point now. But the one on the right is saying it had more than 15,000 likes and 1 million views in 24 hours. We're just going to flip back to our presentation now.
Yeah, of course. So for those who sort of want to know the technology behind this, the large language model that we use is called Burdett Base Squad 2, developed by DeepSet. So how it works, it requires an input that needs a question, which is what the user inputted, and context, which is the data that we also gave it. That was just the side note for those of you who wanted to know. So what we saw in this demo is the difference in quality of answers given by the two different virtual assistants. The one that was trained on DPD clearly knew how to answer questions surrounding DPD than the one that was not. And because we sort of gave it that background knowledge, that data, we in a way equipped it with knowledge and understanding to be able to give more meaningful answers. And we can sort of see the effects on various stakeholders these sorts of things can have, that being a well-trained or not so well-trained virtual assistant. Customer experience will be affected and then can either positively or negatively impact a business's reputation. And not to mention the time, the money, and the energy required to rebuild, retrain, and update these chatbots. And we've not mentioned this, but another problem that could arise by not training AI properly is that biases could arise. So, for example, if we have a company that is using solely AI to screen job applications for a particular job opportunity, and the data that they're using is only based off of their current employees or previous successful applicants, and if they all happen to be predominantly male, then the AI may start to think that the only people who should be able to go on to the next round should be male. And this really disadvantages those who aren't male and are also deserving of this opportunity. And not only this, but also this affects the diversity and culture of a workplace. So I'm going to ask the question now, can we trust AI? So we'd like some audience participation. If you do, put your hand up. If you don't, leave it down. Can we trust AI? One or two? Cool. Well, the answer is, it's up to you to decide. There's no right or wrong answer. So what we wanted to do is demonstrate the importance of training virtual assistants and how it can alter your experiences with them. And we all have a responsibility to understand what's going on when it comes to developing or using things that involve AI. And this allows there to be transparency and upskilling of knowledge when it comes to using these sorts of technologies. And if we train AI or know how that training is applied, then we together can start to actually predict the decisions made, the actions carried out by AI, rather than being completely oblivious to it.
And with that note, we just want to thank you for coming along to our presentation, and we'd like to welcome any questions you may have.
Thank you.
Marvia, do you want to take command of looking for people who want to ask questions? And yeah. Well, I'll do this one, but yeah. Actually, you do that side of the room, I'll do this side of the room. We should have worked this out beforehand, sorry.
Sounds good.
Hi, morning. I really enjoyed it, thank you.
Thank you.
My consideration is that also these language models being trained by the questions we ask. Mm-hmm. So means we can poison it with it. We bias it with it.
Yeah.
And I came about a very good question. I'd like to share that. What is your API key? How about that?
Ooh, interesting.
I've not had that question before.
Yeah. So one thing that comes to mind when we do a lot of like prompt engineering and seeing how we can try and get AI to give us the answers that we want, there's a lot of things that we can do in order to stop things like giving out people's sensitive information, like an API key. So there are some cases where you can tell the AI beforehand, you are a top secret government minister. If there is sensitive information, absolutely do not give this out. But this can take you so far. There are ways you can bypass this. And I'm not going to lie to you, there might not be a foolproof method to stop this from happening. But it's all these sort of preventative measures that you can take to, I don't know, clearly state this is not what you do. And hopefully the AI will take that in and use that as a rule that it will stick to. But once again, it's not 100% foolproof, but these are things that you can do to stop it from happening. Any more questions? I've got one here.
If you've got a question, please put your hand up
Yeah.
and we can be in position for the next one.
Thanks for the talks, really interesting. I was just wondering, it came up a little bit at the very end about trust, and and you brought up transparency and how important transparency is for trustworthiness. I guess with sort of black box models, to what extent can we trust something that we cannot? You talked about the transparency of the training, but the actual transparency of the model itself is kind of impossible. And isn't that like a fundamental reason why maybe we cannot trust something that we don't understand?
Yeah, exactly.
Yeah.
Do you want to take this?
Let you take it.
Okay, yes. So that is a very good point. A lot of these companies, they do try and keep this very black box. They don't want to give out loads of information of how these bits of AI sort of form. That we can't really do much about, other than if we are working within the company. But there are cases where what we do in IBM, we have our own large language models that we use within client projects. And this is where we are very much open to the client, saying that these are all the inputs that go in, and we apply governance. That's a huge thing that's coming out recently, making sure that governance is applied. So not only is it that we're more transparent with what exactly is going on within the large language models, but also the rules that are applied, such as not giving out or leaking out sensitive information. So once again, this is a concern. You can't really do too much about it, based on companies' different ethics or what they decide to do or their business value methods. But it is what we can do ourselves, and that is trying to be as transparent as possible, if that sort of answers what you're saying. Thank you. Any more questions? We've got one here.
Thank you for the talk. It was really great. So I have a question with regard to your virtual assistant version 1. So it seemed to answer with random numbers for any questions with regard to DPD, so I understand it just knows nothing about. So I'm just wondering, why is it coming up with numbers? Why not, for example, something like, sorry, I just don't know this and I cannot answer, rather than just displaying a number?
So the output you get is just as good as the data that you put in. So the data that we put in was just a list of random facts, and the list was actually 1, this, 2, this. So what the virtual assistant would have done, the AI, it would have picked up that number, and that's what it would have outputted. But there's different, that's why training is important, and like I said, we just found whatever and we stuck it in. So if we took the time to actually get rid of the numbers and formulate the data more comprehensively, then that would have not given us any numbers. But because it was listed like 154, whatever, that was why we got numbers.
Hi, I'm so a bit curious about once a company like DPD deploys a chatbot system like that, what sort of processes do they put in place to assess quality after it goes out? What sort of data are they looking at, to see if it's, accurate or not? Is it all quantitative? Do they also do that qualitative? And also, what do they do after to improve it and correct it? Is that an ongoing process, or how does that work?
I can take up the bit about how you test it, and I think that's just going through different series of like user acceptance testing, so releasing it slowly to different people to gather feedback, and then when you're getting bugs, reporting that and making the fixes and changing the prompts to it. I don't know if you want to take the bit about.
Yeah, definitely. And one thing, because we work very closely with clients, is that we always have that constant interaction with them. We have weekly playbacks with them, and they give us all these different bits of feedback that we have to work on for the next week that we present it to them. And in terms of, I think you mentioned how to make sure that it's trained properly, or something about the information we're giving out is sensible or good enough. And that governance, that comes in, and that's the new thing, where we apply different rules, like don't swear, or assess how this is ethical, and just these different rules that apply. That's how we do it. We just stick the chatbot in a system that goes through all these governance sorts of questions and tests if it approves every single step. That's how we do that. Yeah, I think.
Thank you for the interesting talk. I want to ask about, we all know that like large language model AI will hallucinate once in a while. Yeah, there are different technology like RAG, like retrieval augmented generation to have with the reference information so that we know where the information coming from, for example. But then, yeah, like, can you tell a bit more about how you incorporate those into the AI to prevent those hallucinations? And then what kind of threshold that you could set so that you certify that you already have a good enough product to deploy it for the customer?
Yeah, so hallucinations do happen. We've had it a lot where we're working with AI and something pops up and we're like, what is this? What's going on? It's not supposed to happen. And once again, these are things that do happen, and it comes with training the AI or actually building the large language models. Something like we're not really involved with building the actual models, but implementing them. And I think things like rules come in again. That's like, I know this is one thing we keep expressing quite a lot. It's all the rules. It's the prompts that we give the AI models, and just to make sure there could be a statement of this should be relevant to the particular question that was put in. And if the hallucination results in an answer that doesn't do that, it then there should be a blocker, a bit of code that says that's not the case, try again, this and that. And then governance comes in again. We love governance. I clearly love governance. That then goes by and applies the rules and makes sure that the hallucinations don't really happen. But it's a bit of a broad statement, but there are a lot of different steps. But the final piece is governance, to ensure that what we put out is compliant and it is not really giving us information that we're not wanting or is offensive at all.
Okay, that's all we have time for. Final round of applause for Grace and Pardis. Thank you very much.
Thank you. Thank you very much.
Okay, next up, in here we have Chaddy Gosen with Turner & Townsend talking about prompt engineering.